Hi there, my name is Greg Quiggle and I'm the Senior Vice President of Product Management for Kratos Space, and today I'm going to talk to you a little bit about some recent updates with our OpenSpace platform. Sure, we started with OpenSpace now almost 3 years ago, really with the vision of fully virtualizing satellite ground systems. We started our vision really centered primarily on Earth observation networks, where there was a really good value proposition for dynamic ground systems. Essentially, most Earth observation satellites are LEO-based, which means you only see them for a few minutes as they cross over the satellite gateway. What OpenSpace allowed you to do is actually configure the ground system to receive information from the satellite when it's overhead, and also command the satellite for its next mission before it goes over the falling horizon. And we did this with success with several customers. Today we have more than 100 production networks deployed around the world with very large players, including the cloud players such as AWS and Microsoft. Since then, what we've really done is shifted our focus a bit towards Satcom. And we did this because many of the standards that are being used now for Earth observation downlinks follow the same communication standards that are used for Satcom, most importantly DVB-S2 and DVB-S2X. So that drove us to embark on taking OpenSpace and applying it to the Satcom market. We first started by coming up with a virtualized channelizer and a virtualized combiner. We implemented a DVB-S2X modem, all virtually. And then just recently here, we announced our Open Edge platform, which is a remote terminal that runs on generic compute. And finally, V-Stars, which are essentially replacements for what's typically known as a Satcom hub. All of these components within OpenSpace run fully within containers, so they're all container network functions, and they're deployable within a mainstream Kubernetes environment. With OpenSpace, one of the primary challenges that we had to overcome was doing high rate signal processing on general purpose x86 processors. Most of our peers in the industry at some form will have to rely on hardware to do high rate signal processing. That might be an FPGA, might be a GPU, it might be a hardware accelerator card. And what's really unique to OpenSpace is we're able to do all of our signal processing on generic x86 processors. You might ask, why do I care about that? And the reality, there's really two things that drive you to care about it. The first is x86, the Intel architecture, is the most widely adopted ecosystem within IT environments around the world. So what that does is it increases the likelihood that OpenSpace Satcom solutions can actually run within your own IT infrastructure, really limiting the upfront CapEx that you have to spend when you deploy a network. The second is in cases where you do have to add new compute resource. Typically x86 processors and the ecosystem around it cost a small fraction of what you would spend if you tried to build out the same infrastructure on FPGA or GPU. So for our Satcom offering, the first place that we're focusing from a vertical standpoint would be the carriers, so the telcos. And you really have to split this down into two types. You have terrestrial carriers and you have the wireless carriers. For terrestrial, what we've done, in addition to virtualization and containerization, we've actually started to adopt many of the common standards that are used for the telcos today to deploy terrestrial services. Most of their service infrastructure is based on carrier Ethernet, and it's governed by a set of standards with Metro Ethernet for them. Metro Ethernet form through those standards then really allow operators to be able to deploy services across their networks in a way that's touchless and fully automated, and give you automated provisioning, management, billing, everything that you essentially need to run the network. So with OpenSpace, we now allow those telcos to be able to enjoy the same benefits of carrier Ethernet services over the satellite link. Historically, that hasn't been possible. As we look forward to MNOs, it becomes much more about our ability to embrace the 3GPP standards. So 3GPP, third generation public partnership, was established many years ago as a way to drive interoperability within the vendor ecosystem for the wireless carriers. Today, with 5G or 3GPP release 15 and later, there's now a movement to start to bring satellite into that ecosystem around a set of standards that are based on non-terrestrial networks or 5G NTN. So today we're largely carrier Ethernet with the wireless telcos. I think you'll see us start to turn our focus to the MNOs and following the 3GPP standards is the next step.